Hello, Edina Intermediate Algebra students. Today we are covering the first section of our very first topic, which is topic 3, section 1. And we're going to talk about two vocab words that are going to show up throughout the school year, domain and range. At the end of 3.1, we should be able to answer the question of what is a function and how are domain and range important when dealing with a function. Before we get too far, let's just discuss some really good watching recommendations. This is a video, so you have the ability to pause the video at any point to write down ideas that you want to remember. You also could pause, and I'll direct you to do so, to try some of these problems on your own. Make sure if you pause, you can absolutely rewind the video to watch it again if you didn't understand it, or if I move too quickly. Lastly, take notes. It's a lot like if we were in class. These are the important concepts from this section. At the end of the video, I will have a note sheet with some important concepts that I created. You don't have to copy it down, but I recommend that you copy it down or at least look at it to fill in your own notes or to capture some of the main ideas that maybe you missed while going through the video. Let's get started. So we're going to start by just thinking about this machine that I have here. And you guys know about machines. When you put something into a machine, something will come out and the machine does its magic, right? So if I put a Keurig cup in my coffee maker and I press a button, out comes some coffee. Well, for this particular machine, we're going to use the rule that the output, or what comes out of it, is the first letter of whatever word I put in. So for example, if I was to put in the word math, the first letter is going to come out of the machine, which is M. If I was to put in the word zebra, out would come the first letter, which is Z. Now we could keep going, but that's kind of hard to keep track of. So I'm going to create this table and I'm going to write down everything that I put in and what comes out with it. So we already talked about math and we already talked about zebra. What would come out if I put the word school into my machine? Out would come an S. If I put the word Edina in, the first letter would be E. And lastly, if I put the word music in, out would come another M. What we just created was something called a function table. A function table just lists out all of the inputs and outputs that you get when you use that function machine. There's another way of representing this information as well, and that's with using something called a mapping. A mapping is where instead of creating a very boxy table, we create some bubbles. And usually on the left-hand side, we write out our inputs, so the same words that I put into my function. And on the right-hand side, I list out my outputs. Now, something doesn't seem to line up here, but that's because I will not write my repeated inputs or outputs if I have any. Once we have this, we need to tell whoever's reading this which input goes to which output. So math would go to the letter M, so I draw an arrow. Zebra goes to Z, school goes to S, Edina goes to E, and then music goes to M, so I draw an arrow back up to that M. And that's why you don't necessarily need to have repeats. In math, we don't always use input and output, although that often makes more sense. Instead, we're going to introduce these words called domain and range. But what they are is exactly the same thing as input and output. Domain is our input, just another fancy word for it, and range is our output. And we'll summarize this on a later page. Let's look at another function table, this time utilizing numbers. So here, my input was the number 1 and out came a -1. In went a 2 and out came a -2. You can pretty much guess the pattern, I would imagine. Showing that using a mapping, here are my input values, 1, 2, 3, 4, and 5. Here are my output values, all the negatives of them, and then I draw an arrow that shows which input goes to which output. Now, since we are dealing with more numerical values, which we're going to get into more in class as well, I can also represent this information by calling it not only domain and range, but I can say that my domain is my X values and my range corresponds to my Y values. So there's one last way that we can write this relationship, and that's by writing out ordered pairs. I'm going to use what we call in math set notation. And what set notation is I'm going to list out all the ordered pairs in these little mustache brackets or squiggly brackets, as some might call them. So one of my ordered pairs, or one of my input-output, is going to be 1, -1. So I'm going to write that as a parenthesis 1, comma, -1. Now I'm going to list out all of my ordered pairs. So I'm just going to put a comma in between my next set, which is going to be my next pair of input-output, 2, -2. And I'm going to keep listing out these input-output pairs in this set notation. So 4, -4, and then 5, -5. Now, in order to close this up, I'm just going to finish it with that mustache bracket. This is just listing out a set of ordered pairs or input-output pairs within those mustache brackets to kind of keep it as a nice group. So let's summarize some of these ideas. We introduced this word domain. Well, domain is the exact same thing as saying the input of a function. So what do I put into my function machine is what's going to give me my domain. These also correspond to the x values when we're starting to deal more with algebraic ideas. The range is the same thing as the output of the function, which also corresponds to our y values when we're dealing with more algebraic thinking. So let's do a couple examples. Identify the domain and range. So here I have a table and I have a graph. So the table, if you remember, x corresponds to input, which is the same thing as our domain. So I am going to use set notation again, and I'm just going to list out the members of my domain or my x values. So I have a 1, 2, a 3, a 4, and a 5, and I'm going to close that mustache bracket. The range is the same thing as our y's. So this is the same thing as output, which is the same thing as our range, our y values. So I'm going to list those out in set notation. Looks like an 11, and then a 12, and then a 13. Now the next one is a 13, and then a 13 again, and so I don't have to rewrite those. I can just write them one time. So there's my domain and my range. Looking at the graph we have as an example, I have a set of points. Now, we talked about this at the beginning of the school year, but one thing I would suggest is potentially writing out what the ordered pairs are. So this point is -2, -3. Then I have -1, 1. I have this point right here, which is 0, 0. Here I have to go over, let's see, 1, 2, 3, and up 4. And then this one also goes over 3 and up 5. I like to write them as ordered pairs because then it's a little easier for me to see my domain and my range. My domain are all my x values, so -2, -1, 0, and 3. Again, I don't have to repeat those. And my range are all my y values, which are -3, 0, 1, 4, and 5. As a reminder, when you have your points, they are always listed as X and Y. So make sure you keep those clear that that is our range for our Y and the X is your domain. On this next screen, I'm going to have you try a couple on your own. So be prepared to pause the video and try. This time we have a mapping and another graph. I'd like you to identify the domain and range. So please pause the video and revisit us when you have your answer and can check it with what we got. Welcome back. Hopefully you got these same answers as you were listing out your domain and ranges. The mapping is quite easy because they're separated by those two separate bubbles. The graph a little bit more difficult, which again, I would highly recommend writing those out as ordered pairs or points in order to figure out the x values and the y values, otherwise known as the domain and range. All right, so now we're going to talk about some application problems in order to discuss reasonable domain and ranges. So our first problem, Simba is shopping for back to school supplies. Pencils cost 50 cents each and he has $3 total to spend. What would be a reasonable domain and range? So reasonable meaning, are there any constraints? Are there any rules that we need to kind of stay within? So for example, he only has $3, so we obviously cannot spend more than $3. And we need to take into account that pencils cost 50 cents. So what I often like to do is create a table and think about some of the scenarios. So let's talk about what would it cost if I bought one pencil. Well, one pencil costs 50 cents. Now, I left a space out in front because a scenario that most people forget about is there's a possibility that he could actually buy 0 pencils. How much would it cost if he bought 0 pencils? Well, hopefully not anything, because that would be, you know, not nice of the store to charge him from nothing. So he has 0 pencils, cost $0. One pencil costs 50 cents. If he bought 2 pencils, well, now that's 50 cents each, so he is spending $1. If he bought 3 pencils, that would be $1.50. For 4 pencils, it would be $2. For 5 pencils, it would be $2.50. And for 6 pencils, it would be $3. Now, I can't go any further than that because once I start buying 7 pencils, I don't have that much money. So this would be a list of possible domains and ranges or inputs and outputs for this scenario. So if I was going to list out my domain using set notation, I could write 0, 1, 2, 3, 4, 5, and 6. And for my range, I could list out every single value as well. Oopsies. I forgot the mustache bracket, which I often do. So make sure I close that with the right bracket. And that would be listing out my domain and range. Now, something you want to think about as you're doing these problems are there any things that it can't be? So for example, can he buy negative numbers of pencils? No, clearly not. You can't buy negative of something. Could he buy a decimal amount of pencils, like a half of a pencil or 3/4 of a pencil? No. And sometimes I'll call that the fraction amount. No. So our domain or the number of pencils that we can buy always has to be these nice numbers like 0, 1, 2, 3. It couldn't be a decimal. Those types of numbers have a special name, and this is something that you might want to write down in your notes. We have all these different categories of numbers, and you'll see these when you're doing your homework with vocab. We have natural numbers, whole numbers, integers, rational numbers, which are things that can be written as a fraction, and then you have irrational numbers, which are like pi and the square root of 2. They're not very nice. So in this case, I could have 0, 1, 2, 3, 4, etc. So we could consider that a list of whole numbers. So if I go back to this example, instead of listing out every single one of these, I could say whole numbers less than or equal to 6, because I could be exactly 6, or I could say less than 7. But sometimes Pearson is going to have you write out your response using vocab like whole numbers or integers, which is why copying down this page is going to be really helpful for you. Let's have you try this problem on your own. Read through the application of the scenario and see if you can figure out a reasonable domain and range. Pause the video and come back when you would like to check your answer. Welcome back. Once again, I just created a quick table of values to kind of understand what the scenario is is talking about. So the number of people versus the cost that I'm spending. You could list out your domain and range as individual items, or you could use some vocab words to shorten it up. For instance, whole numbers less than or equal to 25, or whole number multiples of 10 less than or equal to 250. Here is the last page with your